The decisive, ultimate success of the monumental D-Day invasion of Normandy on June 6, 1944, rested entirely upon the successful resolution of one massive, seemingly intractable logistical problem: how to efficiently and continuously unload the millions upon millions of tons of critical supplies, tens of thousands of essential vehicles, and staggering quantities of ammunition required to sustain a full-scale invading army across a hostile, heavily defended beach with absolutely no pre-existing port infrastructure. Conventional military doctrine and common logistical wisdom dictated that a deep-water port must be seized immediately and intact to secure the necessary throughput, but the German High Command, aware of this necessity, had heavily fortified every major port along the French coastline with concrete bunkers and formidable sea defences. The revolutionary and brilliant solution, conceived and championed vehemently by Prime Minister Winston Churchill, was an engineering feat as audacious and daring as the invasion itself: the Mulberry Harbors. These were not merely temporary floating docks, but two complete, massive, artificial temporary ports, each equivalent in size and capacity to the massive pre-war port of Dover, which were designed, constructed in complete secrecy across Britain, meticulously towed across the treacherous English Channel, and then rapidly assembled off the vulnerable coast of Normandy. They collectively stand as one of history's most ambitious, extraordinary, and strategically vital feats of wartime civil engineering and logistical genius. The initial conceptual foundation for building artificial harbors to support an invasion dated back to the logistical problems faced during World War I, but the definitive, comprehensive plan for the Normandy operation was solidified in intense planning sessions throughout 1943 under the critical code name Mulberry. The overall design strategy was brilliantly compartmentalized into solving two primary and independent logistical challenges. First, protection, creating a massive, stable breakwater against the unforgiving sea. And second, unloading, providing docks and access roads capable of continuous operation. The protection component involved the strategic sinking of immense concrete caissons and utilizing floating breakwaters alongside scuttling old ships, while the unloading component required ingenious floating roadways and heavy-duty dockheads engineered to safely handle the dramatic, massive 20-foot tidal range characteristic of the Normandy coastline. The British, who shouldered the vast majority of the research, design, and monumental construction effort, designated the finished projects Mulberry A, earmarked for the American invasion sector, Omaha Beach, and Mulberry B, for the British-Canadian sector, Gold Beach. The sheer monumental scale of the required construction project demanded an absolutely unprecedented, highly coordinated mobilization of Britain's remaining industrial capacity and civilian workforce. The finished harbour components, consuming over an astonishing 600,000 tons of structural concrete and hundreds of thousands of tons of high-grade steel, were fabricated across a dizzying array of construction sites that spanned the entire length of Great Britain, from specialised yards in Scotland all the way down to the Thames estuary near London. The critical fixed components included the massive reinforced concrete caissons, phoenixes, which would form the robust outer walls, and the highly specialised reinforced concrete pontoons, beetles, connected to flexible floating roadways, whales, that provided the vital link between the floating docks and the hostile shore. Thousands of civilian contractors, specialized engineers, and tens of thousands of laborers, a large portion of whom were women working in heavy industrial roles, toiled under conditions of utmost non-disclosure secrecy, aware only that they were fabricating very large, hollow concrete boxes for an unknown purpose. The colossal Phoenix caissons represented perhaps the greatest, most visible engineering triumph of the entire project. These immense, hollow concrete boxes varied significantly in size, with the largest caissons rivaling the dimensions of a 5-story office building, often exceeding 60 feet in height and displacing over 6,000 tons of weight. They were meticulously constructed inside massive coastal dry docks, floated out upon completion, and then deliberately and carefully submerged in deep, secluded estuaries around the British coast to effectively hide their overwhelming scale from any German aerial reconnaissance and prevent any suspicion. Their critical purpose was to be precisely maneuvered and then sunk permanently into the Channel seabed at the harbour sites to form the formidable, stable outer breakwaters and wharf walls. This rigid protective perimeter was absolutely essential for creating a secure, tranquil, protected basin within the harbour area, allowing vulnerable cargo ships to safely offload their critical supplies away from the ravages of the open sea and wave action. The overall harbour defence required a dual-layered approach for maximum protection against the powerful ocean swell. The next critical layer involved the massive floating breakwaters, discreetly codenamed bombardons. These were large, distinctive, cross-shaped steel structures that were towed out and firmly anchored in a long, continuous line offshore, positioned strategically beyond the Phoenix caissons. They were specifically designed to absorb the worst initial kinetic energy of the incoming ocean swell and reduce the overall wave heights before the waves reached the static, heavier Phoenix breakwaters. Furthermore, in an immediate, temporary measure, the Allies deliberately sank 50 surplus or damaged merchant ships, known by the code name gooseberries or corncobs, just offshore to provide an immediate, temporary, and rapidly deployable line of protection during the extremely vulnerable initial landings, acting as the first shield for the vulnerable landing craft. The most logistically complex and structurally innovative component of the Mulberry Harbors was the interconnected pierhead and floating roadway system required for continuous offloading. The landing stages, which served as the pierheads, were massive, robust floating platforms, which were anchored firmly to the seabed to prevent drift, but remained completely free to rise and fall seamlessly with the dramatic, cyclical movement of the tides. Crucially, these stable, floating pierheads were connected directly to the hostile shore by a system of flexible, floating approach roadways known as whales. These whales were, in turn, supported by specialized buoyant steel pontoons called beetles. The entire interconnected system was a masterpiece of compensatory engineering, meticulously engineered to handle continuous heavy truck and tank traffic, despite the constantly changing tides, the often powerful waves, and the variable, uneven contours of the Channel seabed, ensuring vehicles could drive straight off the ships and onto the French mainland with minimal interruption. The entire construction process demanded relentless ingenuity and the application of highly specialized, unconventional engineering solutions often solved rapidly on the spot. For example, the flexible whale floating roadways were constructed in standardized heavy 80-foot sections that were intricately designed to hinge, flex, and compensate for continuous movement and lateral stress caused by the channel swell, preventing catastrophic failure. The underlying Beetles pontoons were complex steel floats that were required to possess incredible inherent buoyancy to adequately support the heavy concrete decking of the whales and the weight of the passing vehicles, while also being easily maneuverable by tugboats in the often choppy channel waters during the critical, rapid assembly phase. Crucially, standardization and quality control were paramount. Every single component had to be manufactured to precise specifications to fit perfectly, despite the disparate production across dozens of separate, independent contractors spread across the nation. The deployment phase, codenamed Operation Neptune, began immediately following the successful initial landings on June 6, 1944. As soon as the 5 invasion beaches were deemed securely held, the massive, highly complex towing operation commenced. Hundreds of powerful tugboats, manned by a highly specialized mixture of British, American, and civilian maritime crews, began pulling the colossal concrete and steel components across the treacherous, mined English Channel. The pace was excruciatingly slow, with the massive tows often proceeding at speeds no faster than 4 agonizing knots. This extremely slow, continuous, and highly vulnerable process took several days to complete, relying entirely on Continuous, highly favorable weather conditions, and the crucial, assumed failure of German aerial and naval intelligence to successfully detect or attack the massive, sprawling, highly visible fleet of component tow lines slowly making their way toward Normandy. Upon arrival, the two artificial harbors were rapidly and precisely assembled under continuous fire. Mulberry A was designated and assigned to the American invasion sector at Omaha Beach, near Vierville-sur-Mer, a location already scarred by the heaviest fighting. Mulberry B, the larger, more structurally robust, and more strategically vital of the two harbors, was assigned to the British sector at Gold Beach, near Arromanches. The assembly process itself was a profound triumph of specialized maritime logistics, with highly skilled naval construction battalions, Seabees for the Americans, Royal Engineers for the British, successfully sinking the massive Phoenix caissons with often pinpoint accuracy, achieved through the use of complex, calculated ballasting systems. Mulberry A, the American designated harbor, quickly achieved operational status, receiving its first heavy supplies just days after the invasion, a testament to the speed of the Seabees. However, its crucial operation was tragically short-lived. Just 13 days after D-Day, on the night of June 19, 1944, a catastrophic and unprecedented great storm, a massive 3-day tempest, suddenly descended upon the English Channel. The storm, statistically the worst June gale in over 40 years, completely overwhelmed and shattered Mulberry A. The floating bombardons failed to absorb the massive waves, the pierheads were violently battered off their moorings, and the floating roadways were largely ripped apart and washed ashore, causing massive structural and logistical damage. The swift, total destruction of Mulberry A constituted a major, unmitigated logistical disaster for the Allied operation, severely disrupting the American supply line at a critical point in the ferocious, grinding battle for the Normandy hedgerows. Despite the heavy structural and material loss, the determined American construction units managed to quickly salvage what limited components they could, and the U.S. forces subsequently shifted their logistical reliance onto two simultaneous efforts: a massive, improvisational direct beach supply operation, codenamed Operation Overlord, over the following weeks, and a massive, accelerated push for the rapid capture and repair of the deep water port of Cherbourg. This catastrophic event forced a complete, immediate reassessment of the strategic and structural reliance on artificial ports, brutally highlighting their critical, existential fragility in the unpredictable face of a severe, prolonged natural disaster. In stark, fortunate contrast, Mulberry B, the British harbour at Arromanches, which benefited from a location in a significantly more sheltered bay and was secured with arguably greater stability in its anchoring, largely survived the great storm, sustaining only moderate, localized damage. The tireless, disciplined British engineering teams worked continuously through the storm and immediately after to repair, reinforce, and structurally strengthen the harbour against future threats. Because of its surprising survivability and superior resilience, the British harbour was officially given the distinguished name Port Winston, and it was forced to immediately assume the full, massive responsibility for sustaining both the British and the supply-starved American armies in the weeks and critical months immediately following the crippling storm. For the next 10 crucial months, far longer than its designers had initially planned, Port Winston, Mulberry B, served as the sole, functioning deep-water port for the entire Allied invasion force. During its operational lifespan, it was used to offload an astonishing total of over 2.5 million men, 500,000 essential vehicles, including tanks and trucks, and a staggering 4 million tons of non-negotiable supplies. This immense, relentless throughput was achieved under the constant, pervasive threat from persistent German bombing raids and insidious floating mines, conclusively proving the strategic resilience and operational superiority of the artificial, prefabricated design. The port's crucial ability to operate continuously, day and night, regardless of the significant tidal conditions, was the single most crucial logistical factor that allowed the Allied armies to successfully build up their forces and finally break out of the confining Normandy hedgerows. The inherent logistical bottleneck that traditionally paralyzes an amphibious landing was decisively broken by the operational introduction of the harbors. Before the Mulberry Harbors became fully functional, supplies had to be brought in via dangerous, time-consuming direct beach landings, which were highly vulnerable to high tides, enemy fire, and rough seas. The harbors, particularly the resilient Port Winston, provided a secure, sheltered, and stable 24-hour terminal where large deep-draft ships like the American Liberty ships and smaller specialized landing craft could safely discharge their vital cargo directly onto the secure floating pierheads. The sheer, relentless speed of offloading, achieved often successfully moving thousands of tons of cargo every day, was the crucial determinant that strategically dictated the entire tempo and momentum of the sustained ground war in Western Europe. The specialized engineering required to successfully and permanently sink the massive Phoenix caissons with the necessary precision was considered a high art of hydroengineering. Engineers had to execute meticulous, complex calculations involving water volume, weight distribution, and the precise timing of opening seacocks to sink the huge concrete structures in the correct formation on the channel floor, often with minimal visibility. Once in place, they were structurally filled with tons of sand and gravel to permanently anchor them against the powerful, relentless ocean forces, thereby creating the fixed, secure, and impervious breakwater foundation that cargo ships desperately required for safe docking and offloading operations. The complex whale floating roadways were subjected to relentless, destructive stress tests and material fatigue analysis during their construction phase in the sheltered British Assembly docks. Engineers had to ensure they could structurally withstand not only the immense static weight of tanks, heavy artillery, and supply trucks, but also the continuous, highly variable bending, twisting, and oscillating movements caused by the continuous rolling motion of the sea. Their articulated, flexible hinge design, supported by the buoyant, stabilizing beetles, represented a masterwork of flexible, compensatory engineering, ensuring that the road surface remained relatively smooth and functional, despite the extreme, variable forces imposed by the channel waves. The American decision to rapidly scrap the usable Mulberry components after the crippling storm was largely dictated by the strategic and material realities of urgency and a subsequent operational shift. Recognizing the inherent, non-negotiable fragility of the artificial design in the face of such extreme weather, and the immediate critical need to move supplies to the rapidly advancing front lines, American efforts were immediately shifted entirely toward the accelerated capture and comprehensive repair of the major French ports, most immediately the deep-water port of Cherbourg. This successful strategic pivot meant that U.S. forces relied on rapid improvisation and brute force, while the British successfully sustained the initial, crucial build-up and consolidation through the continued operation of Port Winston. The intelligence security surrounding the Mulberry Project was phenomenal, representing one of the greatest security successes of the war. To successfully maintain the absolute secrecy of the massive, highly visible construction works, the British implemented elaborate cover stories, highly effective camouflage, and strict surveillance. The huge, hollow concrete Phoenix caissons were described by propaganda and controlled leaks as either secret weapons or components of a huge, mysterious tidal power project. This intense, multi-layered security operation ensured that Hitler's command and German intelligence remained completely unaware of the actual function, nature, and ultimate location of the harbors until they suddenly, magically, and devastatingly appeared off the Normandy coast. The British decision to strategically site Mulberry B at Arromanches-les-Bains proved to be the single most crucial factor in its survival. The location was chosen due to its unique geographical advantages, a relatively flat, well-sheltered seabed protected from the worst prevailing winds, and a more favorable, less destructive tidal range compared to other potential sites along the coastline. This inherent geographical advantage, combined with the superior, fixed construction and deep anchoring techniques used by the experienced Royal Engineers, directly explains why Port Winston miraculously survived the devastating Great Storm, while its more exposed American counterpart tragically perished. The total manpower commitment to the construction and subsequent operation of the Mulberry Harbors was immense, requiring the massive mobilization of specialized, highly skilled labor forces not traditionally associated with frontline warfare. Naval architects, specialized civil engineers, sophisticated concrete specialists, and tens of thousands of dedicated civilian laborers worked tirelessly alongside military construction teams, like the Royal Engineers and the Seabees, unequivocally demonstrating the total industrial and human commitment required from the entire Allied war machine to launch and sustain the invasion. The core logistical brilliance of the Mulberry Harbors lay in their fundamental concept of total prefabrication. By building the complex, massive port infrastructure entirely in safe British factories, shipyards, and coastal assembly docks, the Allies completely bypassed and eliminated the months-long bottleneck of building a complex port from scratch on a highly contested hostile battlefield under enemy fire. The only thing required on the hostile French shore was rapid precision assembly and anchoring, effectively transforming months of potential, exposed construction time into mere days of full operational readiness. The eventual phasing out of the Mulberry Harbors came several months later, not due to any fundamental structural failure of Port Winston, but simply because the strategic necessity for them diminished. As the powerful Allied armies successfully advanced, captured, and subsequently repaired the major, permanent French deep-water ports of Cherbourg, Rouen, and ultimately Antwerp, the critical logistical center of gravity shifted naturally eastward. Consequently, the need for the artificial temporary ports decreased, and their components were finally deemed surplus to requirements in the spring of 1945. The most prominent, undeniable, and visible legacy of the Mulberry Harbors remains today at Arromanches. The enormous concrete Phoenix caissons can still be seen permanently sitting on the Channel seabed, where they were sunk over 80 years ago, a massive, imposing testament to the scale of the engineering ambition. They collectively serve as a powerful, silent, and permanent memorial to the strategic genius, the unprecedented technical collaboration, and the sheer, overwhelming industrial muscle that was required to ensure the Allied invasion could be not just launched, but successfully supplied and sustained against all odds. The true, deep engineering miracle of the Mulberry Harbors resided in their elegant principles of flexible modularity and standardization. The entire system was conceived, designed, and executed as a giant, precisely interlocking kit of parts. Regardless of the specific variable depth of the sea floor or the constantly changing height of the tide, the standardized whales, beetles, and phoenixes could be successfully and reliably connected, ensuring the seamless, continuous flow of supplies. This unparalleled, flexible design made rapid, reliable, and continuous assembly absolutely possible under intense combat conditions and variable natural environments. Ultimately, the Mulberry Harbors were the indispensable logistical insurance policy for Operation Overlord and the success of D-Day. They guaranteed, with engineering certainty, that the Allies could continue to land the overwhelming torrent of men and essential material even if their primary objectives, the major French ports, were not taken quickly or were rendered unusable. While Mulberry A was tragically lost, the resilient Mulberry B provided the critical logistical breathing room and the continuous flow of supplies that allowed the entire invasion to successfully transition from a vulnerable beachhead into a fully established operational Western Front, proving definitively that the success of the Normandy invasion was built not just on the courage of soldiers, but on tons of ingenious concrete and reinforced steel.